So today we have a class on complex analysis, and we here I am going to solve GATE 2025 complex analysis question related to residue and pole. So let us see how we solve it. So what we have been given. Uh, we have been given that I equals 1 upon 2 pi I sin j dz upon 1 minus cos z cube. Over the region mod x plus mod y equal to 1, then you have to find 160 I equals what. So firstly we have draw the region mod x plus mod y equals 1 and it is a rhombus whose side length is 1, and now we shall solve it. So let us see how we solve it. For that what we'll do, first we find the pole. So for to find pole, firstly we put denominator equals 0. So put denominator equals 0. That implies it will be cos zq equals 0. That implies cos so is cos zq equals 0. That implies cos zq equals 1. That implies we can say zq equals 2n pi, uh, where n equals 0 plus minus 1 plus minus 2 dot dot. So firstly we put n equals 0. That implies zq equals 0. That implies z equals 0. When we put n equals 1, that implies zq equals 2 pi. That implies z equals 2 pi over 3. And it would be, you can clearly see, it is greater than 1. It is 1 point something. So it is greater than 1. So it will not lie inside the given region. Again, when we put n equals minus 1, that implies it will give z equals minus 2 pi. That implies z equals minus 2 pi whole 1 by 3, and it will again less than minus 1. So again it is minus 1, so it will lie outside the given region. So keeping this in mind, we can see clearly that it also lies outside the given region. So finally, we can clearly see that z equals 0 only lies inside the given region, and it is our required pole. Okay. Now we want to see what is the order of this pole. So for that region, we see fz equals sin z upon 1 minus cos qz. As the given integration, as you can see, given integration is fz dz. So by comparing it from the previous slide, you can clearly see fz is sin z upon 1 minus cos zq. So now I am solving it. So for that we simplify uh, the given function, and for that we have to keep two things in mind. I am to find the pole. We always know that pole is nothing but just the coefficient of 1 by z. Pole is coefficient of 1 by z in the Taylor expansion. In the Taylor expansion. So if we are able to find the Taylor expansion efficient, then we can clearly find, or we can easily find the pole of fz. So for that, we want to find how to expand them. So as we already know that sin x equals x minus x cube upon 3 plus x5 3 factorial x5 upon 5 factorial minus dot 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 and cos x equals 1 minus 1 minus x square by 2 factorial plus x4 by 4 factorial dot dot dot. Okay, so using these things, we have to expand the given function. So our f would be sin z divided by 1 minus cos cube z. So we also know that 1 minus cos theta equals 2 sin square theta by 2. These are the some previous result which we have studied these things in class 11th. We have studied these things in class 11th. So we have studied these things in class 11th. This is 11th class. Okay. Sin x equals x minus x by 3 and cos x equals 1 minus x by 2 plus x over 4. These are the expression of sin x and cos x. Now we also know 1 minus cos theta equal to sin x per theta. Using these things, we find the Taylor expression of fz. So firstly we simplify fz. It is nothing but fz. So 1 minus cos qz, it is not qz. It is zq. Z. Okay. So 1 minus cos theta 2 sin square theta 2. So it will be 2 sin square z q by 2. So it can be approximated to z upon 2 into zq upon 2 whole square. As we know that sin z can be approximated to z. So it would be resulted into z upon 2 into z6 upon 4. But it can be written as 2 upon z to the power 5. So we have to nothing to take with what the concept are appearing here. We have to only take with or we have to consider about what is the order of pole. And so one can see easily that order of the pole is nothing but power of z numerator and which is equal to 5. So we have a pole of order 5 now. So what we have done here, here we have find the order of pole in the Taylor expansion of fz, and it is the required uh, what order of pole. Now let us move ahead and see what we can do. Yeah. So now we have to find the required z2, and it is coefficient of 1 by z. So z equals z minus zq upon 3 plus z5 upon 5 factorial minus dot 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 divided by 1 minus 1 minus z6 upon factorial 2. Why it is z6? Because sin z z cube, it is nothing but you can see easily how we have written this. It is z cube Let us see. So it is ZQ upon 2 factorial plus ZQ square upon 2 factorial plus ZQ power 4 upon 4 factorial, so minus. So what we have done here, we have find the expression of sin z upon 1 minus cos zq. Here it is nothing but fz equals sin z upon 1 minus cos zq. And we have found its Taylor expansion. So it can be written as z minus zq upon 6 plus z5 upon 120 uh, plus dot 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 divided by z6 upon 2. We have nothing to take with what any other terms are appearing. We have to find the residue, and for that we need only coefficient of 1 by z. So for pole, we need the coefficient of 1 by z. So one can easily see you will get 1 by z from here. And what is the residue? So what is the coefficient of 1 by z? One can easily see it would be z5 upon 120 into 2 upon z6. So it will be cancelled out and it will be resulted into 1 upon 60 z. So what is the coefficient of 1 by z? It is equal to 1 upon 60. So it is our required residue, and we know what we know. We know by the Cauchy residue theorem, by Cauchy residue theorem, I equals 1 upon 2 pi I into 2 pi I into residue. And what is residue? It is residue of Fz around the pole. And what was pole? Uh, residue of Fz at z equals 0. And what was it? It will be cancelled out. So it will be related to what was 1 upon. So and what we have to told to find, what we have been told to find. We have been told to find 160i. So that implies 160i would be 160 into not once, not 160. Let us see. It would be 160 into I means 1 upon 60. So it is 80 upon 30. 80 upon 30 and it is 8 by 3. So it is our required answer. Okay, thank you. Let us see next video.